Need help? Call our cybersecurity team and book a consultation with us today.
All right. Hello, everyone. Thanks for attending our SOC-as-a-Service webinar. So a couple just housekeeping items just to begin with. In the bottom right, you should see kind of three dots that you can press. There, we do have a Q&A section. Feel free to ask questions. The Q&A will come at the end of the webinar, but we'll try to answer as many questions as we can in the allotted time. So just to introduce ourselves, my name is Michael Kim. I am the security lead at LA Networks. So a little bit about LA Networks. We've been in business for 20 plus years. We are an engineer-driven company. You know, other bars you may have seen are salespeople with engineers. We're more engineers with some salespeople. We are headquartered in Los Angeles, but we do work on a national and global scale. Our organization is 70% engineers, with a quarter of those being CCIEs. And 90% of our engagements are repeat customers and referrals. So we are pretty good at engineering, and that's what kind of leads us to getting more business. Our areas of expertise are managed services, IT security and surveillance, data center and cloud, network and wireless, and collaboration. For this specific webinar, we are partnering up with Kevin from Xenix, who I will pass it over to so that he can introduce himself.
Thank you, Michael. My name is Kevin Niku. I'm CEO of Xenix. I'll talk about Xenix later on for just a few minutes. This is not a sales presentation. You know, what I'm going to cover is mostly educational. And to get started, first of all, checking to see if you could see my slides to proceed. Okay, great. So let's get started. Thank you for joining us. And today I'm going to cover basically the state of cybersecurity, what the situation is today. Then I'm going to walk you through what I call an attacker storyboard, which is how an attacker and a ransomware works through an environment. And then we talk about Xenix for just a couple of slides, followed by a Q&A. So let's get into it. Let's start with the state of cybersecurity. So I think we should talk about people, because there's a lot of attacks and ransomware and the like that's caused by the perception of how people see cybersecurity. 43% of employees are not aware that clicking a suspicious link or opening an unknown attachment in an email is likely to lead to a malware detection, a malware infection. 1 of 4 believe that transferring files to a file server in the cloud and then getting it, you know, in another location, it automatically is protected. Of course, that's not the case. 48% of attacks are through Microsoft Office files, Excel, Word, and the like. 1 of the 3 employees feel that if they don't have secured their laptops with or mobile devices with their password, then it's no risk. 39% of people think that if they use social engineering, it's okay, but 59% of them don't know what a social engineering attack might look like. And of course, the downloads, which causes all kinds of havoc. So this is a people's problem, partly. But the attacks that are mainly coming out from, the internet, the hackers, it's really ransomware that has taken a big share of that hackers' attacks. 40% growth. 22% of consumers have had experiences with malware. Phishing, as you probably have heard a lot about it, has become the dominant way to compromise a network. 67% increase in cybersecurity breaches. And that's since 2019. I've got another slide that talks about what's happening now. And of course, social engineering, as I said, is a big problem right now. So if you take that information and look at the numbers, it's astronomical. I'm breaking it down here, $16.4 billion per day. So break it down per hour, per minute, and per second. You could see you could see the numbers on the slide. It is a pretty big number. So it's a pretty big problem right now as we speak. This slide is very interesting because most people don't know, particularly in this section, that average cost of a remediation from a ransomware attack is 1.85 million. The total cost average is 4.2. That includes the damage to reputation, fixing all of that, and of course fixing all the IT related. But when we talk about a compromise, it's not just the IT that's the issue. It's really what happens, the revenue loss, the reputation, and the cost of bringing everything back to normal productivity. So this is continues to be a big problem and very expensive problem. And suffice to say, and probably you've figured it out, that these attacks are increasing in a very rapid. This graph shows you that it's kind of linear function going straight up. And FBI reported that consumers have continuously, year over year, have reported a lot of problems with cyber attacks, and the cost of those have gone up tremendously year over year. But you think that organizations say, well, it's not going to happen to me, right? But at least one successful attack has been observed by 82% of the organizations on the average. And every year it's going up. And most organizations believe that it's more likely that they're going to get attacked. And if you're in any of these verticals, you could see what the response was and what the industry and what market feels the likely of an attack is. So everybody recognizes this as a big issue. But the ransomware in 2021 became a big issue. Everybody knows, probably you know, about the Target, which was a Target attack, which was a supply chain issue. It was not Target that was attacked. It was one of the vendors that was not protected, and the hackers got into the vendor partner, and through them, and through the supply chain, they got into Target. So it's no longer protecting the environment on its own, but it's also protecting the environment from all the business partners that you may have. Through that connectivity, they get in. And ransomware, it has become a big issue when they lock your devices, your computers, and they ask for the ransomware to release it. It continues to get bigger and bigger because they know how to monetize that. And one of the biggest reasons for that is unpatched systems. So if you don't patch your systems, it gives the hackers an opportunity to get in. And of course, phishing is the way I'll talk about phishing a little bit more. But phishing is the number one way that they get it. So frequency of the ransomware attacks, you could see what has happened. It went from 40 seconds to 11 seconds. So there's an attack every 11 seconds now. And if you think about the downtime, it's pretty much across every organization, small, medium, and large, and it's pretty significant downtime. The graphs show that it's pretty normalized across all kinds of organization. Now, what's happening today? This is the latest statistics that I've collected from 2022. The largest ransomware from Acer, 50 million. 37% of the businesses were hit by ransomware in 2021. It's expected that the ransomware will cost the world $265 billion by 2031. Again, the average cost of remediation is 1.85 million. And so on and so on. So I don't want to read the slide to you, but you can tell just by the statistics that it is a big problem. And this problem is growing not just because of the servers, routers, firewalls, and what you might have in your environment, but it's really IoT, Internet of Things, your watch, your refrigerator, and anything that's connected to internet, manufacturing devices that have some connectivity to the internet. They're susceptible to this. So it's no longer the IT devices that are sitting in a data center or in your office or in the cloud, but anything that's connected to internet allows visibility. A good example of it everywhere right now is security cameras. They're connected to internet and nobody thinks of them as a potential risk, but they actually happen to be pretty susceptible to ransomware attacks. So now that we framed the issue, let's take a look at how an attacker might work its way through this environment. On the right side of the slide, let me first explain what this is and then I'll walk you through it. On the right side, you will see a typical office. You've got workstations, servers, you've got connectivity to the internet. And on the left side here, you've got something like a data center. It could be AWS, it could be Google, it could be Azure, it could be a physical data center in some location. Your workstations and employees connect through the internet to that particular server location. For the sake of argument and consistency, let's call it AWS for now. And the data flows through these workstations to the data center, and the transactions are happening between your employees' workstations and probably some server with some information, databases and the like, patient information, credit card information, all of that sits in some secured location. So what happens when there's a spear phishing attack? That particular malicious code is downloaded to a workstation. Of course, that employee does not know that it was a phishing attack. They clicked on a link or an email attachment that unloaded that particular malicious piece of code into that workstation, not knowing that that workstation has been compromised. The employee continues working. And at that point in time, that malicious piece of code that the attacker put in that workstation starts talking to, I call it mothership. In this case, it's called C2 here. So it starts talking to C2, passing information. Then that particular malicious code starts looking at the environment and says, okay, how can I find where the admin is so that I can get more information from that environment? So it starts going across the network, looking through the traffic to see where that admin workstation is, and follow that. It actually laterally moves to that admin workstation and plants the same code, malicious code, in that workstation. Now the admin workstation is compromised. Now all of this sometimes is done, most of the time these days, is done in memory. So it's very hard to detect that something is running. In the past, it was file-based, but now it's memory-based, causing it to be a lot more difficult to detect. Now, once that implant is in the admin workstation, now that admin workstation is now connecting to the mothership and giving information, as much information as it can, to that bad reputation IP that's in the cloud. Then the attacker starts looking around to see what's interesting around it. Can I get more information? Can I find a way to get even more information, not just about the users, but also maybe I can get patient information. Maybe I can get credit card information. Maybe I can find information about the customers. And in this scenario, it says, okay, they're protected. I cannot go. So how can I do this? What they do is that they connect, because they're already sitting on the admin workstation, they connect through AD to the secondary AD, which is in AWS, and then plants yet another malware into that server. And from there, now that they established themselves in AWS, they start looking around again to see. First, it connects to the mothership to say, hey, I'm here, I've got connectivity. And then they start looking around to see what interesting information they can detect in the environment. Once they find that information, let's say customer data, on a file share, then they start copying it and then exfiltrating that data through a secured connection to the mothership, like that. So at that point in time, the entire environment is compromised, both at the local level and at the data center level, with all these attacker compromised devices continuing to communicate with the bad reputation IP in the cloud. Now, to make it a little bit more easier to understand, I take the same sequence of events and I've displayed it in 3 levels. The blue is representing the desktop, the employee. The green is how the bad actor is behaving across the network and what it does, and red is how it actually goes to the mothership. So as you could see, the compromised PC or workstation, because they clicked on a phishing campaign, gets compromised. They establish the connection to the C2, the bad actor website, and at the same time they go figure out who the admin is. They escalate the privileges and the memory, and then they go work themselves to the Active Directory on the local side, and they run a power script, which has the highest privileges within the Windows environment, to make its lateral move. Now at that point in time, they install it in the other workstation. They extract all the admin credentials, and then they start looking around to see what's interesting. And through PowerShell, again, they make a lateral move, and they go into with an HTTPS tunnel. They make the connectivity. They do a port sweep, and then they look at the data, collect the data, enumerate files and the information that they've collected, and then they mount a file share and then copy all the files to the mothership, the bad actor IP address. So you could see this sequence of events touches pretty much every part of the network. And the reason I'm illustrating it this way is to show that it's not one point of attack. When attackers get in, there's multiple points that they're active within the environment, and that needs to be monitored and controlled and taken care of quickly, so that you stop the compromise from happening. Okay, so what do we do? Who's Xenix, and what do we do? We are SOC-as-a-Service, which means that we do anything that has to do with security products, installation, configuration, assessment, vulnerability scanning, pen testing, monitoring 7/24, and remediation. We rebranded the company as Xenix to focus on security as a service and not the platform. The platform is ours. We've developed this platform over the past 10 years. It's very comprehensive. It's millions of lines of code, and it has approximately 15 modules that are all integrated, working together, and our employees are trained and actually certified on our platform, and they use this platform to monitor our customers' environment 7/24, 365. We do this from 2 locations in Santa Monica, California, and Pune, India, and we're opening new SOC locations as well. This is a multi-level, multi-tenancy platform, which means that all the cost savings are passed on to the customers. We are end-to-end SOC as a service. If you remember the slide that I was talking to you about, part of it is detection, right? we need to detect what's going on at any point in time at any part of the network. We need to investigate what's going on with that compromise. It's not just looking at something like an alert, but also trying to figure out what's the root cause, what's the payload, what was the impact, and then find a response. In our platform, we have both autonomous response as well as supervised response. Autonomous response takes action automatically based on certain rules that you put in place, but we typically don't do that for mission critical servers where it needs to be supervised response. You don't want to automatically shut down an operational server that takes the whole company down. So there is some give and take when we talk about autonomous response and supervised response. And when some vendors say, oh, we just do supervised response because we know everything, that's overreaching in my opinion a little bit. And then of course, all of this has to do with management and tuning. Because we maintain the logs and the incidents and events, I should call them, because we're not just log bases. And that's an important point here. We are not looking at logs to make a decision. We look at the entire events, whether it's network events, host events, IPS, IDS, NIDS, network intrusion, as well as logs that are coming from a variety of devices, routers, firewalls, servers, but also security applications. So let's say that you're running a particular security application environment that can give us telemetry about that particular application, such as maybe you have a Zscaler, which is a cloud firewall. It's an application, it's not a device. So we can connect with Zscaler and grab the security information to see what's going on, and then we generate alerts and alarms from that. Which brings us to the integration. We have full integration capabilities. We have our own API that connects with all the popular products in the industry, databases. We also have integration through industry standard protocols such as syslog. And we have full integration with the cloud, popular clouds such as Azure, Google, and AWS. And everything that I said is monitored 7/24. We have built-in XDR as well, which I just mentioned, explained just a minute. So when we look at all of this, it's important to recognize that as a fully agnostic platform, we can take telemetry from virtually any device from anywhere. I should say any device or application. So in this illustration, the gray boxes are just samples. They're not intended. This is not a full list, but I'm trying to show some categories of security devices and applications just to bring the point home. Of course, servers, routers, firewalls, switches, all of that is typical devices that everybody has. But as we move into email security, web security, network security with AI, endpoint protection, email and phishing protection tools, Office 365, and the like. As you could see, it's a wide variety of applications, devices, and operating system. And all of that telemetry comes into our platform. So some of the tools that are built into our platform, again, this is not a log-based platform. We have an enterprise SIEM and log management. We have a hacker diversionary system, IT asset discovery, vulnerability scanning and pen testing. We have HIDS. We have asset discovery, but also analysis of those assets. We have user behavior analysis. We have retention and archiving. So if you're tied to any compliance requirements such as HIPAA, which requires 7 years, we could virtually have unlimited retention and archiving. Of course, all of this comes with a full library of reports so that you could, and custom reports as well, so you could get the information that you need. And that's addressed in a full lifecycle management of a SOC. All of this plays into a cross-correlation engine. Why is this important? because you don't want to look at a particular event at what point in time. You want to look at what's happening across the enterprise because you're getting telemetry from different devices and application. So you get an enterprise view of that application, of that environment. And as a result of that, we've created something called Enterprise Risk Meter. Enterprise Risk Meter was asked, a lot of the CIOs, CISOs have asked us, I don't want to know that I've got all these alerts. That's too many alerts, too many alarms. I want to know, I want to have a tool that tells me that if I click on it, I can get the list of top 3 things that I got to do to reduce my risk. Well, we created that tool. We call it Enterprise Risk Meter. That it's literally, it looks like this. And it goes from 0 to 10, 10 being the highest risk. And you get a gauge based on an algorithm that we've built. You click on it, and this is the screen that you can get. And then it lists all the top incidents and ranks them from high to low, and then you know what to do, which is the most highest risk incident, what to do is to resolve it to bring the risk down in the environment. And of course, I mentioned we have a built-in XDR. XDR is a proactive tool that brings different telemetry from endpoint protection, network detection, and protection tools, as well as logs and all of the other devices. Now, it happens that we collect more telemetry and we address it in our XDR, and it doesn't matter if it comes from us or from somebody else. So by bringing all the telemetry, which we don't have any limitations to, and we can take as many telemetry as possible, our XDR can therefore give a more accurate threat detection and threat analysis. So in a nutshell, why Vertex? We have been in business for 10 years, actually 11 years, purely focused on cybersecurity monitoring and remediation. We are not a consulting firm who's delivering this, and we're not a network management company who's doing this. We are purely focusing on that. We own our own intellectual property, so we don't have any third-party licenses that we have to pay. As a result, we have a very high value proposition, and we pass on those cost savings to our customers. The platform is very comprehensive. It covers A to Z. You could see the list here. So, but you could choose, let's say that you use a vulnerability tool that you like and you already have it in place. We can take that out, the results of that vol scan and import that into our platform automatically. And that can also participate in our cross-correlation engine. So it doesn't necessarily have to be our tool. That's part of our philosophy about being completely agnostic and allowing the customers to preserve the investments that they've already made in their environment, but also play into the latest and greatest technology and take advantage of what we offer in our platform to complement what they already have in place. And because it's designed to support our partners like LANet, it allows you to have, to leverage the relationship that you have in place with full visibility into the environment. You have access to our platform. You see what's going on. LANet sees what's going on, and of course, we're managing it in the background for you. So everybody in the food chain has full visibility into what's going on. We are not a black box, so you see what we see. We also, all of this comes with what I did not get a chance to talk about a lot, which is our delivery, because as much as we talk about the platform itself, which is behind the scenes, the delivery mechanism is just as important, because at the end of the day, customers want to make sure that they're protected. So it's on us to make sure that we have the best delivery and let our customers know what's happening and be able to manage and detect, manage, remediate as quickly as possible. Okay, I think I'm right on time after 30 minutes to hopefully be able to answer any questions you may have.
There was one question that already came up in the chat window. I think it's during the ransomware portion. Like, what does it look like if we are hit by ransomware? Does it get blocked? I think they're kind of wondering what the process for that would look like.
Well, Is the question about ransomware already hit or ransomware prevention?
I would go prevention, I would say.
Okay, so in order, yes, a SOC as a service tries to prevent. I cannot say that it's 100% guarantee because there's no guarantees. The hackers are getting more sophisticated. They're using AI. What we can do is to reduce the chances of them getting in. So yes, it does protect against ransomware because it detects what's happening in the environment, particularly if EDR and NDR is put in place so that you could see any abnormal behavior, unusual traffic within the environment. And then on the workstation side, you could even turn on autonomous response so it isolates that particular attack on that. If I go back to, let me go back to my, uh, so in this environment, if you have, for example, EDR and NDR, or any of our other tools, it detects the compromise here or here, and it actually can shut down the workstation by quarantining it and then sending an alert. And then we look into it and say what's going on, and we inform you. And if it's on the network itself, our protocol analysis and net flow also tells us what's going on. And if somebody's trying to connect to the mothership, as I called it before, then that's where our protocol analysis and network analysis kicks in, as well as the other tools that shows that, hey, somebody is trying to exfiltrate data um, uh, to some bad reputation IP in the cloud. And that's also prevents it from happening. So in general, yes, we we could prevent it, but it's not, I would say it's not 100% guarantee. Nobody can say that it's 100% guarantee. There's no such a thing. We can just try and do our best. But I would say there's a better than 90% chance that it can be prevented.
Yeah, I think the storyboard you showed is kind of like a good representation of all the different steps that has to be done before you get hit by the actual ransomware. So yeah, with a good SOC in place, you can generally possibly catch it at like any of those steps to kind of prevent the ransomware from spreading. Okay.
Yes, that's why this slide was there, because at any point in time, you could see that it can be detected using some of the tools that I mentioned.
Yep. All right. Next question is, how much of a cost difference is there between, I guess, employing a SOC as a service versus trying to build up a SOC? Do you have any customers that maybe transition from SOC as a service to a SOC, or is there like a break-even point?
Actually, it's the other way around, because building a SOC and having it 724, it's not as easy as it may sound. I have had multiple of customers in the past that had their own SOC, and they realized they cannot uh, manage it 724. They cannot hire and retain cybersecurity staff. There's a big turnover. You have to have subject matter expert at any point in time. You have to be in the industry to see what are the latest attacks, what are the latest information that's passed on from different groups to the cybersecurity community. So there's a big focus on cybersecurity when you're in this business that cannot be done if you have your own SOC and you have to manage it. It's a much bigger task. And also when it comes to cost, it's much more expensive because you have to have dedicated people for one particular environment. Whereas when you have a multi-level, multi-tenancy platform and you bring in your own staff in there, they monitor multiple of customers at the same time, and that reduces the cost for any one customer. There has been a lot of studies on this, and there's a lot of publications on the internet. If you search, you can find them, that shows the pretty significant savings when you do a SOC as a service versus actually building your own SOC. The uptime of the platform what platform, servers in the cloud, storage, and then 7/24 monitoring. You need different shifts. People go on vacation, people get sick, so you have to have additional resources ready to go. It is a big undertaking for some companies. I would say that Fortune 500 does that, but we are seeing a lot of companies below Fortune 500 who are interested in SOC as a service, and they're moving away from having a SOC internally because it's not their core competency.
All right. Next question is, how long does it take to set up the solution? So I guess from initial engagement, how long to get like a fully functional SOC-as-a-Service up and running?
No, that's an excellent question. We can install our sensor. These green boxes that we put in here are sensors, right? Ours. And the green boxes are actually what we call a sensor, is monitoring the environment and also talking to everybody in this environment, application servers, and over here as well. So it takes us less than 4 hours to install a sensor. And after that, we work with LINet or the customer directly to point their critical systems, such as routers, firewalls, and the like, to our sensor. Typically speaking, in let's say a day or two or maybe 3, depending on the size of the customers and how large the environment is up and running. Then we go through a benchmarking period for about 2 weeks. That's our job. What we do is that we look at every element in the environment. Are they reporting? If they're not reporting, why are not they reporting? Are we getting enough information? Are they reporting the right amount of information? There's categories and subcategories of security from different applications, operating systems, and the like. Do we get that different levels of category and subcategory, and so on? So the benchmarking process is to fine-tune the environment while the actual monitoring is going on. So I would say that was a long answer. The short answer is that you could be up and running the same day or the next day for a smaller environment. Larger environment might take a little bit longer because you have to touch workstations and servers and routers and firewalls and the like. But we also have a 2-week benchmarking to make sure everything is fine-tuned and optimized for that environment.
All right. Next question is, can Xenix help with incident response planning and playbooks?
Yes, that's a professional services. We do have a package for incident response planning. We also have packages for security policies so that the customers can deploy those security policies within the environment. Believe it or not, we've had customers with PCI issues, with HIPAA issues, that don't have any security policies in place. So we help with that, and we help with incident management, incident planning, and the red teams and all of that.
All right. And then what ticketing systems does Xenix work with? And then what type of things does the product actually monitor? I know we talked about it a little bit. This may want a little bit more detail.
Yeah, sure. So we have our own integrated ticketing system, but customers have full access to that. There's a portal that they can log in and they look at all the incidents. What are the high priority incidents? Who's working on it? What's the status of that ticket? We have a 1-hour SLA for critical incidents. We have an escalation process, so it's not one size fits all. Our customers can choose how they want to escalate. Like they say, between 9 and 6, this person needs to be contacted. After 9 p.m., don't call me unless it's a major issue, or call this other person. So all of this is customized. The ticketing system that we have also integrates to the customer environment. Let's say you use ServiceNow or any other ticketing system, and it's automated. So you don't even have to come in and actually log in and look at the tickets. you could send an email and get a response with an email. So it's all fully automated, and the integration to a third party can be done as well.
All right, and then the next question is, can Xenix help with remediation if we've already experienced or been affected by ransomware?
Yes, that's professional services. So let me explain the different services. 724 monitoring comes with remediation recommendation. Our customers never get a automated response to a machine-generated email. Every incident is fully investigated, and we make sure that we understand the root cause. So when an incident is reported to a customer, it has why the customer is being contacted, what's the root cause that we detected, what has happened in the environment, and what's the remediation recommendation that either the partner, in this case LANet, can do, or the customer can do on their own. If there is remediation that requires professional services from us, that is not a subscription fee that goes into the monitoring. That's actually a remediation professional services engagement or project, and we can help with that as well. In addition to these services, we have cybersecurity assessment, vulnerability scanning, and pen testing, and a few other things. You could see them on our website. That are professional services that help customers go from different maturity levels. For example, we have a very comprehensive assessment tool, which includes a very detailed questionnaire with 2 engineers and a CISO level senior person that we package that all together, that does the assessment, the gap analysis, the roadmap to full cybersecurity coverage, and the steps in the middle and what needs to be done to get there, and recommended tools. All of that is part of this assessment that I mentioned. So there are different levels of engagement, and there are different remediation techniques that we use. That was the long answer again. The short answer is yes, we help with remediation, but we prefer to be ahead of it so that as much as possible we prevent a compromise and not having ransomware attacks within the environment.
All right. Can you describe your pricing model?
Good question. It's very straightforward. We've learned throughout the years that customers don't like surprises. They don't like change in pricing. They don't like not knowing what their exact budget should be. So we have a very simple model. It's per reporting source. A reporting source could be Azure, AD, server, router, firewall, switches, but we don't charge for traffic. We don't price it based on aggregate data. We don't price it based on the storage that we use in the back end, because it comes with initial storage. And if the customer wants to do a lot more, it's just a matter of just adding storage, but it comes with the starter storage. So everything is bundled into one price, and we do it based on number of devices. So if you have 100 reporting sources, that's times a number, and that's the budget per month. Hope that answered the question.
Yep. All right. I don't think I see any more questions coming in. I'd like to thank Kevin for presenting today, teaching us a little bit about SOC-as-a-Service and Xenix and what they can provide. So if this seems like something of interest to you, if you'd like to learn more, if you'd like to see the product in action, there's a couple ways you can go about it. If you just visit us at la-networks.com, we do have a contact us page where you can just reach out. It'll go to some of the people here, and we can work to schedule the demo, or you can just email me directly. I know some of the people in the webinar already have my contact information. So yeah, just reach out and we can kind of go on to the next steps to let you see the product, see what it can do in a more focused demo. All right, so I'd like to thank everyone for attending today, and please reach out if you have any questions, or if you'd just like to learn more, or just want to maybe discuss your specific situation. All right, thank you. Bye.
Thanks, everybody. Bye-bye.
Need help? Call our cybersecurity team and book a consultation with us today.